how to solve a system of linear equations. On the first video, we talked about how you can solve a system of linear equation with like two variables using the old algebraic method like substitution, elimination, addition, and subtraction. But now, what do we do when we have a system of equation with three variables? So this is the example problem we'll be doing, and this is the equation. So how do we solve a system of linear equations with three variables and we have three equations? So one of the best methods to do it is by using the Gaussian elimination method, by using augmented matrices. So first we need to create an augmented matrix. Let's create an augmented matrix using the equations we have. We just need to look at the coefficients. So this is the augmented matrix we have using the system of linear equations, and we use Gaussian elimination to solve it. So when you use Gaussian elimination, you need to take care of two main points. First is to know pivot points. Pivot point should always be 1. No matter what, pivot point should always be 1. And this is my idea, like general idea, not my idea. This is like use a staircase as in triangle like this. If this is your pivot point, go down here. This is your next pivot point. If this is your next pivot point, make a staircase again, go down here. So this is your next pivot point. So try to make the pivot point 1 and you choose the next pivot point using the staircase. So let me erase this, rewrite it again. So this is the matrix we have. Our main idea has to be get the pivot points 1. So always start on the far left side, the first entry, then go down, make everything 1. I'm just gonna put up the solution for this. Solution is so this is the solution for the matrix. So what we did here is make the pivot points 1. Also, then another important point is all the entries below the pivot point should be a 0. So if this is 1, if this is our pivot point, all the entries is 0. So we do the staircase, go here, next pivot point, all the entries below it should be 0. We go to next entry point, next pivot point, it's 1. We don't have anything below it. So this is the reduced form.